Jupiter is not a gas giant. That sentence has been in your textbook since you were a kid, and it's wrong. Not simplified. Not slightly off. Wrong. The largest planet in the solar system is not made of gas. It is made of liquid, and underneath that liquid is something so strange that the people who study it for a living still can't agree on what it is. We've been staring at Jupiter for over 400 years, since Galileo Galilei first pointed a crude telescope at it in 1610 and noticed 4 tiny points of light orbiting it like a miniature solar system. Since then, 9 spacecraft have flown past it, settled into orbit around it, or dropped a probe straight into its atmosphere. And after all of that, 4 centuries of watching, 9 separate machines built and launched at enormous cost, scientists still cannot tell you with confidence how Jupiter actually formed, what's really sitting at its center, or why it's hiding an ocean's worth of water in a place it shouldn't be. This isn't a knowledge gap out at the edges, some minor detail left to future missions. It's a gap at the center of the planet itself, literally. In May 2017, NASA held a press conference to share the first real scientific results from its Juno spacecraft, which had been orbiting Jupiter since July 2016, dipping to within a few thousand miles of the cloud tops on each pass. Scott Bolton, Juno's principal investigator at the Southwest Research Institute, stood up in front of reporters and said something that undid decades of textbook diagrams in a single sentence. "There seems to be a fuzzy core," he said, "and it may be much larger than anybody had anticipated." Bolton wasn't describing a minor correction to a footnote. He was describing a planet that doesn't match a single one of the models built to explain it, and he was the person best positioned on Earth to know. Here's what we thought we knew. Jupiter, a ball of hydrogen and helium gas wrapped around a solid core of rock and metal roughly the size of Earth. Clean, simple, layered like a planet should be. Almost none of that holds up. Start at the top. The swirling cloud bands you see in every photo, the cream and rust-colored stripes that make Jupiter look like a marbled orange, the endless storms, the great red spot itself, are only about 50 kilometers deep. That sounds like a lot until you compare it to the planet underneath it. Jupiter's radius is nearly 70,000 kilometers. So that entire visible cloud layer, the only part of Jupiter humanity has actually seen with its own eyes across 400 years of telescopes and cameras, makes up less than 0.04% of the planet. If Jupiter were shrunk down to the size of a beach ball, its clouds would be thinner than a single coat of paint. Everything below that coat of paint isn't gas anymore. It's liquid. Keep this image because we're going to come back to it. Jupiter isn't really a ball of gas at all. It's closer to a planet-sized ocean, wearing a very thin, very violent sky like a coat. That ocean idea sounds almost peaceful. It isn't. As you descend past the clouds, the temperature climbs and the pressure builds so fast that hydrogen gas simply stops being able to behave like a gas. It compresses into a liquid, not because it's cold, the way water freezes on Earth, but because it's being crushed by the sheer weight of everything above it. This liquid hydrogen ocean reaches a depth of about 20,000 kilometers. Take Earth and its larger, icier cousin Neptune and line them up end to end. You'd still barely reach the bottom of this one layer. That should have been the strange part of the story. It isn't even close. Keep descending, and the pressure climbs to something almost absurd. Tens of millions of times the pressure at Earth's surface. At that point, the hydrogen atoms themselves start to come apart. Electrons rip free from their protons, and the liquid stops acting like a fluid and starts conducting electricity the way a metal does. Scientists call it liquid metallic hydrogen, and this layer is roughly 40,000 kilometers thick, about 3 Earths stacked one on top of the other just to cross it. This layer isn't just a strange curiosity. As it churns and spins with the planet, it generates Jupiter's magnetic field, by far the strongest of any planet in the solar system, strong enough to blast the surrounding space with radiation that would kill an unshielded astronaut in minutes. Engineers had to bury Juno's most sensitive electronics inside a titanium vault just so the spacecraft could survive long enough to take these measurements at all. So add it up: 50 kilometers of visible weather, 20,000 kilometers of liquid hydrogen, 40,000 kilometers of electrically charged metallic hydrogen acting like a planet-sized dynamo, and we still haven't reached the center. This is where the story used to get simple. Underneath all that liquid, the old model said, sits a solid core, rock and iron, compressed into a dense ball, sitting quietly at the middle like the pit of a fruit. That's the part Juno was sent to check, and that's the part that broke. Juno doesn't have eyes that can see through 70,000 kilometers of hydrogen. No spacecraft does. Instead, it measures something far more subtle: the tiny wobbles in Jupiter's gravitational pull as the spacecraft skims low over the cloud tops, wobbles caused by exactly where the planet's mass is concentrated. Fly close enough, often enough, and those wobbles become a map of the inside of a planet no one will ever cut open. When mission scientists finally ran the numbers, the core wasn't where it was supposed to be, and it wasn't shaped the way it was supposed to be either. Instead of a compact ball, Jupiter's heavy elements, rock, iron, and hydrogen, turned out to be smeared together across a region spanning nearly half the planet's diameter. There's no clean edge where core ends and ocean begins. It just fades, gradually, the way sugar spreads through water once it's stirred in, instead of sitting at the bottom as a solid lump. Researchers now call it, officially, a fuzzy core. And here's the part that shouldn't be possible. Computer simulations of planet formation are unambiguous. Over billions of years, heavy material sinks. It settles. It separates cleanly from the lighter elements around it and forms exactly the kind of solid, well-defined core the old textbook diagrams promised. Every serious model says Jupiter should have sorted itself out by now. It hasn't. 4.5 billion years. And the core is still fuzzy. This isn't even the first time Jupiter has surprised us mid-mystery. Back in July 1994, a broken-apart comet called Shoemaker-Levy 9 slammed into Jupiter's far side in a string of impacts over several days, each one releasing more energy than humanity's entire nuclear arsenal combined. The impacts happened on the side of Jupiter facing away from Earth, so almost nobody on the ground could see them directly. But by pure coincidence, NASA's Galileo spacecraft was already in transit to Jupiter at the time, still years from arrival, and from about 240 million kilometers away, it had a clear line of sight that nothing on Earth did. It watched the impacts happen in real time, frame by frame, as flashes of light bloomed and faded on the planet's dark side. When scientists later analyzed the light from those fireballs, they found something they weren't fully expecting mixed into the debris: water, sitting deep in an atmosphere that, according to the models, wasn't supposed to hold much water at all. That single anomaly helped build the case for sending a dedicated orbiter, Juno, to find out just how much water Jupiter is really hiding, and where. Juno has been circling the planet since 2016, still taking measurements, and the honest answer, all these years later, is we still don't fully know. Think about what that actually means for a second. Gas giants like Jupiter aren't some exotic exception tucked away in a corner of the universe.